Okay, so you guys can see my screen now?
Yes.
Okay, so here is so here's a brief summary again. Quick brief summary. The zeroth law of thermodynamics says that if two objects are in contact and they're at the same temperature, no net heat is exchanged. The first law of thermodynamics is that change in internal energy of a system is the heat added to the system minus the work done by the system. This is just an energy conservation principle. Okay, so that's the first law of thermodynamics. So this chapter is about the second law of thermodynamics. Now you need an additional law if these existing laws cannot explain phenomena that you observe in nature. Okay, so here's a phenomena that you observe in nature. Okay, so let's say this end of the room is hot, this end is cold, and I've drawn two pictures of this. What you observe in nature is that heat flows from the hot end to the cold end. You never see heat flowing from the cold end to the hot end. Now, this is perfectly fine with an energy conservation principle, because if heat, even if heat flowed from here to there, the total energy is still the same. So the energy conservation principle is not being violated. So the first law is not violated in this case, but still you never see this in nature. So the question is why? Okay, so that's why you need an additional law. You need another law, the second law of thermodynamics. And what the second law of thermodynamics states is, well, it introduces a quantity called entropy, which measures disorder. And what we find is when heat flows in this direction, entropy increases. And if heat flowed in this direction, entropy would decrease. So the second law is just a statement saying that only processes that in nature occur that where entropy either increases or stays the same. Okay, so only processes where change in entropy is greater than or equal to 0 are allowed. Okay, and that is the second law of thermodynamics. Okay, then we'll talk about heat engines. So heat engines, what heat engines do is they take heat from a hot reservoir, convert some of that to work, and dump the rest of it out to the environment, the heat that cannot be converted to work. Your car engine typically is, your car engine is a heat engine. It burns gasoline. It burns a gasoline air mixture in the engine block. From the heat released, it converts some of that to the motion of the car, and the rest is dumped out. Your car engine is about 20% efficient. So again, let me say this in a different way. For the $5 of heat released, only $1 is converted to work, to the motion of the car, and $4 are dumped out into the environment. Okay, so anyway, that's a heat engine. Refrigerators are, what they do is they remove heat from a cold environment and they dump it in a hot environment. Okay. Now, of course, nature doesn't want to do that. You just saw that heat doesn't want to flow from a colder temperature to a hotter temperature. So how do you do this? Well, you have to do some work to be able to do that. And that's what a refrigerator is. Okay. So you're removing heat from a cold environment by doing some work and then dumping it into a hot environment. So in your refrigerator, it's cold inside your refrigerator, and what the refrigerator does is it removes heat from the inside and dumps it into the kitchen, which is hotter. Okay. So that's the refrigerator. Okay, those are the topics we'll talk about. I will pause again, and then we'll go into